used for the calculation of a pH value. Now, in the case of pharmaceutical analysis 1, you are having the problems with respect to calculation of pH by using this equation. That time, sir will discuss with you. Now, we will move towards the important point from our syllabus, that is buffer solutions or buffer system. Now, we all know what is the meaning of the word buffer. Any solution which will resist the change in the pH value upon addition of small volumes of either acid or a base, this solution is known as buffer solution. Now, this buffer solution is composed of weak acid and one of its salt. So when we are going to consider acetic acid and its salt, either sodium acetate or ammonium acetate, or a weak base and its salt, ammonium hydroxide or ammonium chloride. This is a combination of the buffer system. Now, the purpose to resist to a greater or lesser extent the change in the pH when some acid or base is added to them. Now, what are the types of buffers? Basically, the buffers are classified as strong acid buffers, strong base buffer, weak acid buffers, and weak base buffer. Now, strong acid buffers are concentration of oxonium ion is high in the case of nitric acid. So, this is a strong acid buffer. Then, strong base buffer, check using the equation of pH plus POH is equal to 14. Then weak acid buffers, a buffer solution with a constant pH value. Generally this strong acid buffer and strong base buffer, nobody will use for the pharmaceutical importance point of view. For the understanding purpose only they are there. We are going to use which type of buffers? Weak acid buffer. Buffer solution with a constant pH range between 4 to 7 can be prepared from a weak acid and its salt. So when we are going to prepare a salt of weak acid, that is sodium acetate in aqueous, so it will, after dissociation it will give acetate ion and a sodium ion. Then acetic acid is only partially ionized. So acetic acid, so it is basically a mixture of acetic acid and its salt, that is sodium acetate. So this is actually an example of weak acid buffer. When ज्यावेळी आपण मिक्सचर घेतो कुणाचं acetic acid आणि sodium acetate, this mixture is coming under the category of weak acid buffer. Then weak base buffer. Now what is the speciality with respect to the weak acid buffer? It will have the pH range between 4 to 7. Now the speciality with respect to the weak base buffer, buffer solution with a constant pH value between 7 to 10. So when we require a pH range for the pharmaceutical substance must be between 4 to 7. That's why that time we are going to check which type of buffer? Weak acidic buffer. And when we require a pH range between the 7 to 10, that time we are going to consider this weak base buffer. Now what is the example of weak base buffer? This weak base buffer is a solution of ammonium hydroxide and its a salt, that is ammonium chloride. So this ammonium hydroxide and ammonium chloride combinedly can be used as an weak base buffer to prefer a pH range between 7 to 10. Now what are the significance and applications of buffer pharmaceutically point of view? For the standardization of pH meter. Now there is one instrument in the laboratory to check the pH of any solution. This is known as pH meter. And the pH meterचं standardization करायचं असेल, calibration करायचं असेल, whether the pH meter is working properly or not, that we can check with the help of by using these buffer solutions. Then it is also used for the buffering of biological systems. So when we are going to preserve any blood or it is made compatible with the other persons, so we have to maintain the pH value of the buffer. So buffering biological systems like blood for the maintenance of pH, for the preparation and formulation of eye drop, because these organs are very sensitive towards the pH of the solution. So eye drops and shampoo, to maintain the pH value of these formulations, we are going to use buffer systems or buffers. So these are some of the importance of buffer. Now, buffer equation. Consider a buffer solution obtained by mixing weak acid and its salt Ma. So already we have seen the equation of pH value and pKa value. That equation is known as Henderson-Hasselbalch equation to calculate the pH value. Now we are moving towards to discuss the buffer equation. And for this equation, we are going to take a mixture of weak acid and its salt. So the dissociation of weak acid, that is Ha, can be written as Ha is equal to H plus plus A minus ion. And the dissociation of salt, that is Ma, can be written as M plus plus A minus ion. So this is an dissociation products of all those weak acid and its salt. Now, the degree of dissociation will depending upon the value of dissociation constant Ka. The degrees of dissociation of all those are depending upon the dissociation constant, that is Ka. Greater the magnitude of Ka, that means greater the magnitude of acid constant Ka, greater its dissociation. If acid dissociation constant is more, then the dissociation of acid, that is Ha, is more. That time we can write the Ka is equal to H plus and concentration of H plus multiplied by concentration of A minus divided by concentration of Ha. So this is an acid dissociation constant of that acid. Now, making the approximation that in the dilute solution, activity is equal to the concentration. So this relationship exists in a mixture of Ha and Ma. Therefore, if we are going to do the dissociations of this, if we are going to rearrange the equation in this manner, so if we are deriving H plus to the right hand side, so Ka multiplied by dissociation of Ha divided by dissociation of A minus ion. Suppose the concentration of acid is Ca and the concentration of its salt is Cs. See here what we have done. We have written the equation for the acid dissociation constant Ka. Then we have write down the rearranged equation of by taking H plus ions on the left hand side. That then by rearranging the equation, Ka multiplied by Ha divided by A minus. Then if we are going to write or assume the concentration of acid is Ca and concentration of salt is Cs, so the concentration of undissociated acid will be Ca minus H plus ion, that is Ha is equal to Ca minus H plus ions. So this is undissociated form of acid. So in this buffer solution, A minus ions will be produced from the dissociation of Ma and also from the Ha. So the concentration of Ma, that is salt, is Cs. The concentration of A minus ion will also be Cs. A molecule of Ha and its dissociation gives H plus ion and OH minus ions. So basically A minus is equal to H plus ion. So thus the total concentration of A minus ion in the equation is Cs plus H plus ions. So when you are going to take the screenshots and write down these equation in your notebook, this is very simple to understood, but you have to write down on the notebook. So This is actually a buffer equations when we are going to take the uh, solution of HA and MA, that is salts of its conjugate base. So these are some of the formulas. Minus log and is or can be written as a P. Then log of A divided by B is equal to log of B upon A. What is the formula for the calculation of pH value? pH is equal to pKa plus log of salt divided by acid. Similarly, for the buffer solution containing a weak base and its salt, it can be shown that this is a formula for the calculation of pH. If we are going to calculate the PaOH value, that is hydroxyl ion concentration, so instead of pKa, pKb is there plus log of salt divided by its base. So whether we have to determine the pH value or PaOH value, the respective changes must be there in the formula. Now we are moving towards the next point, that is buffer action or buffer capacity. Now, what is the meaning of the word buffer action? The reaction responsible for maintaining the constant pH upon addition of acid or a base in buffer solution is called as buffer action. आपण ऍसिड आणि बेस ऍड करून सुद्धा जर त्या सोल्युशन मध्ये पीएच चेंज होत नसेल तर अशा टाईपच्या ऍक्शनला काय म्हणतात? बफर ऍक्शन. त्या सोल्युशनला काय म्हणतो आपण? बफर विच विल रेजिस्ट द चेंज इन द पीएच व्हॅल्यू. बट कुठल्या ऍक्शनने तो रेजिस्ट करतोय चेंज इन द पीएच व्हॅल्यू? दॅट ऍक्शन इज नोन ॲज बफर ऍक्शन. The buffer action of acetic acid and sodium acetate mixture can be explained as below. Acetic acid is weak acid and it's partially ionized into acetic